Welcome to this tutorial for DMAP version 2.1, the Drought Monitoring and Analysis program from AgriMetSoft. We begin on the Stations tab, where every DMAP project starts. Across the top are the three workflow tabs. The toolbar provides application controls, export all data, and the progress bar. Stations may be entered directly in the editable list of stations grid. Each record can contain a name, latitude, longitude, field capacity, surface soil, and available water capacity. For faster setup, click Fill List by File and select the prepared workbook. In Get Data, choose the station sheet, keep first row as header selected, and leave conversion at none. Map station name, latitude in decimal, and longitude in decimal to the corresponding station fields. The preview shows Station 1 and Station 2. Map FC to field capacity, SS to surface soil, and underlying AWC to available water capacity. Then click Load Data. DMAP adds both rows and plots them as blue markers. Use the map controls to inspect the locations, then open the Data tab. On the Excel subtab, rainfall is selected under Store as Variable. Click Open File and choose the workbook that contains the monthly rainfall series. Select Monthly Rainfall. Input Data Preview displays the date, month, Station 1, and Station 2 columns. Set input timing to monthly based on your Excel file. Retain the detected date format and map date. In this example, I have only rainfall data, and I'll download the average temperature. Click Load Data. The confirmation reports that rainfall was loaded successfully for two stations across 26 years, from 1993 through 2018. Rainfall remains available in memory. Now switch to the Download subtab to add another climate variable directly from an online archive. Heat download panel lists GPCC, NCEP/NCAR reanalysis, CPC global precipitation, NOAA star vegetation products, and CMIP 6 projections. Select NCEP/NCAR reanalysis. Set the date range to 1993 through 2018, same as rainfall data, and retain the monthly timescale. Rainfall is selected first, but DMAP detects that rainfall is already loaded and warns that downloading would replace it. Select TAVE from the variable list. The progress bar and download log track the requests. DMAP stores 26 years of monthly average temperature for both stations. Click Export All Data. T-average is labeled downloaded, while rainfall is labeled imported. Select either variable to preview its monthly table. Close this window and open Drought Indices to begin the drought analysis. This tab groups the available indices into meteorological, agricultural, and hydro and remote families. Controls are enabled only when their required climate variables and station properties are available. SPI is available because rainfall has been loaded. The year range is automatically set to the common 1993 to 2018 record. Set timescale to monthly and select a 9-month accumulation period. Click Calculate, then acknowledge the index calculated message. Click to Table to display monthly SPI values by year. Choose the line chart type and click Plot to draw Station 1's 9-month SPI series. Use the Station selector to add Station 2 and plot again. Both station series can now be compared, with the optional horizontal reference line and other chart settings available at left. We have different analysis here in DMAP. Click Wavelet to examine how the SPI signal varies through time and frequency. Wavelet analysis opens full screen and runs automatically for Station 1. The upper left scalegram shows wavelet power, the upper right plot shows global power and its threshold, and the lower chart shows the original SPI series. You can change significance from 95 to 90%, set Morlet omega 0 to 8, and run the analysis. The status line now reports one dominant period equal to 2.47 year for 312 time steps and 26 scales. Warmer colors identify stronger localized power. The white cone of influence curve marks regions affected by edge effects, while the global spectrum shows whether a peak crosses the selected significance threshold. Click Teleconnection Analysis. Because DMAP does not supply a built-in climate index, select a monthly CSV file. Here, ONI_monthly is used for the Oceanic Nino Index. The Teleconnection window compares SPI with ONI overlags from -12 to +12 months. Both Pearson R and Spearman Rho are shown in the chart and table. The summary identifies the strongest Pearson correlation as 0.300 at a positive 1-month lag, meaning ONI leads the drought index by 1 month under the displayed sign convention. Change the significance level from 95 to 99%. The significant column updates using the stricter confidence level, while the correlation coefficients, valid pair counts, and p-values remain visible for every lag. Return to Wavelet analysis. Results may be exported to a multi-sheet Excel workbook, and Export Charts PNG saves the scalegram and global spectrum graphics. Open the station list and select Station 2. DMAP recomputes the transform for the second SPI series. At these settings, the status reports no dominant period. Close the window. Back on drought indices, click Multiscale to compare SPI behavior across several accumulation periods at the same time. The Multiscale SPI and SPI heatmap window opens. Keep index set to SPI. Use scales 1, 3, 6, 9, 12, and 24 months. Select Station 1 and click Generate. The heatmap places time on the horizontal axis and accumulation scale on the vertical axis. Redder cells indicate drier conditions, greener cells indicate wetter conditions, and the gray starting wedge is the required run-in period. Select Station 2 to regenerate the view. Use Export Plot for PNG, SVG, or PDF output, or export to Excel for values and statistics. Close the heat map and return to the main results. Click Trend to open Trend Analysis. The window immediately evaluates the currently calculated moving 9-month SPI series. The default method is Mann Kendall plus Sun slope. Set significance to 0.10 and run Station 1. The table reports the statistics, direction, slope, and significance, while the dashed line shows the fitted trend. Select Station 2 to recompute the same test for the second location, then return to Station 1. Station changes trigger a fresh analysis automatically. Select Modified Mann Kendall to apply the Heimdrau correction. The table and fitted trend update automatically. Next, select Spearman's Rho for a rank-based trend test. Select Linear Regression to display its fitted trend and statistics. Finally, choose Innovative Trend Analysis. The chart compares sorted record halves around the red 1-to-1 line. Export if needed, then close. To extract drought episodes, enter -1 in threshold, keep below selected, choose Station 1 and click Analyze. Values below -1 will be grouped into individual drought events. The Drought Events window lists each event's interpolated start date, duration in months, cumulative severity, and peak departure. The chart shades every run below the red threshold line and labels its severity. The Tools panel can export the event table, save the chart as PNG, or create a complete Excel workbook containing events, time series, and chart. Click Frequency Analysis or SDF to model event rarity. Severity Duration Frequency Analysis uses 14 events from the 26-year record. The summary reports 0.54 events per year, Kendall's tau of 0.648, and a fitted Gumbel theta of 2.844. The upper table and SDF curves give fitted severity for representative durations at 2, 5, 10, 25, 50, and 100-year return periods. The lower table ranks historical events using joint and joint or copular return periods. For example, the longest and most severe listed event begins in May 1997 and receives the largest fitted joint return periods. Export to Excel preserves the curves, historical results, and method information. Then close SDF. Close the Drought Events window to return to the SPI table and comparison chart. The calculated index remains available for further analysis. We have rainfall and temperature, so we can only calculate the PDSI index. Check them in Export All Data window. Hovering over PDSI shows that it requires rainfall, PET, surface soil, and available water capacity. Since TAV is available, click Calculate PET to create the missing evapotranspiration input. The PET calculator lists Thornthwaite and Hammond for temperature-only data, Hargreaves-Samani for daily maximum and minimum temperature, and FAO, 56 Pendemonteith, for the full meteorological input set. Methods without sufficient data are disabled. Choose Thornthwaite, which uses average temperature and each station's latitude, then click Calculate PET. DMAP computes PET over the selected year range for both stations. The confirmation reports that PET was calculated successfully for 2 of 2 stations. PDSI, PHDI, SPI, RDI, and other PET-dependent choices can now become available. Use Export All Data to verify the new PET variable. It is labeled Calculated, with Thornthwaite identified as the method, and its monthly values can be previewed alongside rainfall and TAV. Close the preview, select PDSI under Agricultural Indices, set the timescale to yearly, and click Calculate. DMAP explains that the Palmer water balance method has no direct yearly form. PDSI is calculated at monthly resolution and then averaged for yearly display. This is not the same as recalculating from yearly aggregated data. Acknowledge the warning. For the native Palmer output, change timescale to monthly and calculate PDSI again. Confirm the index calculated message. The table now displays monthly PDSI for Station 1. Choose the line chart and click Plot to view the full Palmer index. Click Wavelet to analyze the monthly PDSI series. At 95% significance and the default Morlet setting, the window shows the PDSI scaleogram, global spectrum, raw time series, and 1 detected dominant period. Close the window after reviewing the plots. Next, open Trend Analysis. Mann Kendall plus Sen slope is applied to monthly PDSI. The table summarizes the test, while the dashed line shows the estimated trend. Thank you for watching this DMAP version 2.1 tutorial. In the next videos, we will focus on each analysis separately and explain how to interpret its results correctly. We will cover drought indices, trend analysis, wavelet analysis, drought events, and frequency analysis. Please like this video, subscribe to the AgriMetSoft channel, and visit agrimetsoft.com for more information.